So we have mapping notation here. And mapping notation is another way to show transformations of sine waves. So you'll notice we have this equation. Y is equal to negative 2 sine 1 over 3x plus 5. Here is like your parental, they'll call it a parent function of it, where you have variables instead of values. So very quickly we know that the a value is negative 2. I've even color coded them. B is 1/3. There's actually no c value written in. So what that actually means is c is equal to the value of 0 because we're adding 0 and makes no changes. And d happens to be the value of 5 in this case. Okay. Now, mapping notation takes into account that you already know the major coordinates of the function you're using. For instance, sine. We talked about how some of the major coordinates for sine, we'll quickly write them out. We'll do a quick table here, is x and y. Okay. And when x is 0, y is 0. When x is pi over 2, y happens to be 1. When x is pi, y happens to be 0 again. 3 pi over 2 is negative 1. And then I should have given myself, oh no, wait, what am I talking about? I have more room. There we go. And then finally, 2 pi, we're back at 0 again. And that's how we get that wave type function to it. We'll draw it on a graph. What's good about mapping notation is if you have this information memorized, we can use these equations to find out the new coordinates without having to really go through the process of stretching everything, compressing everything. This is a different take at it. So we have these values. Xn, that's the new x value, and xo is the original or the old x value. So what I'm going to do is I'm going to take each of these sets of coordinates. We're going to run them through the equations for mapping notation to find a new set of coordinates. So we'll have a new x and a new y value in this point. Okay? So the very first one here, remember the new x value, we don't need those. The new x value is equal to the old one, which happens to be 0, divided by b. b in this case is a third. So to divide something by b, or to divide by a third, is actually the same as multiplying by 3. I'll write it out this way, as if you're dividing by a third. And you technically add c also. And when we add c, c happens to be 0, like we talked about above. So what happens actually to this one here, 0 divided by anything is 0, plus 0 is also 0. So the x value hasn't changed. That's the exact same. But the y value is a little bit different. The new y is equal to the a value times the original y, which we said was 0, and d happened to be plus 5. So our new y value, negative 2 times 0 gives us 0, but we also add 5 to it, so we end up at 5. So you'll notice the new coordinate is changed from 0, 0 to 0, 5. So we have our new coordinate. So we've actually ran it through all the potential translations and stretches and compressions by using mapping notation. We'll do the same thing again, and then we'll kind of infer the rest of it from there. Pi over 2 is the next one, okay? So this is where it gets a little tricky. Our new x coordinate is equal to the old x coordinate, which is pi over 2, okay? And that is technically divided by the value of 2. And then we have to add c, so think of this as its own set of brackets, and c was still 0. Now when you divide by 2, think of it by inverting and multiplying, if you remember your old fractions rules. So it's going to look more like this. So in retrospect, it's actually going to be pi over 4. So our new x coordinate is going to be pi over 4. And what's the y coordinate going to be? Well, that's going to be yn is equal to, we take that negative 2, we multiply by the old y value, which was 1, and then we add 5. Okay? When we do this, we get negative 2 plus 5 is equal to 3. So this is the new coordinate here. And you would essentially go through this process over and over and over again to get the rest of it. It's a bit slow, but it does help when you get confused with the transformations and compressions to stuff. So what I'm going to do here is I'm going to turn off some of these old ones here. This is the original sine wave. I'll zoom in a bit on it. Remember with the original sine wave, our news wave was actually negative 2 sine, I believe it was 1/3 x plus 5. Okay, so if we zoom out a little, you'll notice this is a very different looking wave. First of all, it's been shifted upwards. It's been elongated. So instead of being horizontally compressed, it's actually been horizontally stretched. Think of it like almost like multiplying by the value of 3. I think I did that mapping notation with the wrong number. But we multiplied by the value of 3, and then we stretched it by a factor of 2. So this wave looks a lot more like, or looks very different from our old one here, okay?